evaluate the definite integral x into dx from a to b as the limit of sums. Let's begin with the solution, and we have integral of a to b x into dx. Now, by the definition of integrals as limit of sums, we know that integral of fx into dx from a to b is given by b minus a into limit 1 upon n as n approaches to infinity, f of a plus f of a plus h plus so on up to f of a plus n minus 1 into h, and here h is equal to b minus a upon n tends to 0 as n tends to infinity. Now in this case the given function fx is equal to x. This implies that f of a is equal to a, f of a plus h is equal to a plus h, and f of a plus n minus 1 into h is equal to a plus n minus 1 into h. Therefore, in this case, integral of x into dx from a to b is given by b minus a into limit of 1 upon n as n approaches to infinity. First we have f of a, that is a, plus f of a plus h, that is a plus h, plus so on up to the last term is a plus n minus 1 into h, and this is equal to b minus a into limit as n tends to infinity of 1 upon n. Now here we see that a is n times, so we have n times of a plus h plus 2h plus so on up to n minus 1 into h. So this can further be written as b minus a into limit of 1 upon n as n approaches to infinity, na plus, taking h common, we have 1 plus 2 plus so on up to n minus 1. Now we know that sum of first n terms is given by n into n plus 1 upon 2, and here the terms are n minus 1. Therefore, this can further be written as b minus a into limit of 1 upon n as n approaches to infinity, na plus h into, here the last term is n minus 1, so we have n minus 1 into n minus 1 plus 1, since this is the sum of first n terms, and this is divided by 2. So this is equal to b minus a into limit of 1 upon n as n approaches to infinity, na plus h into, from here we get n into n minus 1 upon 2. This is equal to b minus a into limit of 1 upon n as n approaches to infinity. Now taking n common, we have a plus, here the value of h is b minus a upon n into n minus 1 upon 2. So this is further equal to b minus a into limit as n approaches to infinity, a plus n upon n minus 1 upon n into b minus a upon 2. So this is equal to b minus a. Taking limit inside, we have limit as n approaches to infinity of the function a plus limit as n approaches to infinity of the function 1 minus 1 upon n into b minus a upon 2. So this is equal to b minus a into, now a is independent of n, so we have a plus, here we have 1 minus, as n tends to infinity this term becomes 0. So we have 1 minus 0 into b minus a upon 2, and this is equal to b minus a into a plus of b minus a upon 2. This is equal to b minus a, 2a plus b minus a upon 2. This we get on taking LCM. And this is further equal to b minus a into, here we get a plus b divided by 2. So we can write this as 1 upon 2 into b minus a into b plus a. And this is equal to half b square minus a square. Therefore, integral of x into dx from a to b as the limit of sum is given by b square minus a square upon 2. This completes the solution.